All right, so we're gonna just start today by going over the homework, which I thought would be all great and perfect, except for I realized there was a word in question 1. It is kind of defined, but I think I'm missing a page of the packet. I think that's what happened, because we never really talked about what an unconformity was. It was in the reading that we did, but we never really got into details about it. So it does tell you an unconformity is a buried erosional surface. I would like to go back to page 15 and add that to our pictures and descriptions here. I really think maybe it just got cut off. I think it was supposed to be here in the first place. So as the question said, it is a buried erosional surface. And I'm going to demonstrate it with Play-Doh like we've been doing. So give me a second while I make some layers here. Oh, perfect. I had some layers left over from yesterday. So a buried erosional surface. There's actually going to be another bullet in there once we kind of go over it. So we talked about this a couple times this week, plus last long time ago. How do the rock layers form in the first place? Sorry. How do the rock layers, the layers that I've been stacking up like this, what's the steps in them being made? Mrs. Ritz? That's okay. No. Yes, did I forget to mark them answer? Okay, I'll fix it. Get right. All right. Pieces of rocks. Okay, so first of all, we have pieces of rocks. So rocks get deposited. Remember, that's the first word? Yep. Or sediments get deposited, buried, compacted together. So these will all get buried, compacted together, and you'll have a nice, flat, horizontal layer. Then what happens on top of that? Same thing. And what happens on top of that? Same thing. Now, what happens if in the meantime, why do I always do that? All right. What happens if in the meantime, so we had the pink layer, the purple layer, and a new pink layer. What happens if a glacier comes through the area right about now? What might the glacier do to these layers of rock? It would what? One thing it'll do is create a U-shaped valley. What will it do to the rocks? Move them. So what if the glacier came through and removed that layer of rocks? What's missing now? The rock. Literally, the rocks are missing. This whole rock layer is missing. Now, is there any evidence that that rock layer was there? No. You don't see any evidence that there was that pink layer? No. None? Oh, you might not be able to see it. Okay, I can see it. Hang on. I think you can now. Any evidence? Where'd it go? Any evidence now that the pink layer was there? On that. See, there's some pink there. Freaking heck. We can see it, Mrs. I know, but it's, oh, there's some pink right there. Okay, so there's still some pink on this. So there's a tiny bit of evidence that there was a pink layer there. If this was real life and a glacier had gone over these layers, what evidence would there be that a glacier went through? Scratches, the U-shaped valley that we talked about before. So glaciers will leave evidence that they were there, but they take their whole rock layer and make them disappear. So what if there was a fossil of a Martian in this pink layer? A Martian, alien from Mars. It would be classified. But the glacier removed this layer. So The fossil, where's the fossil of the alien then?
On the other layer. I don't know.
What'd you say, Ella? Somewhere else. It's gone. Whatever was in this layer that got removed is gone. It's missing. I like to relate this. What if the only way to know about the United States history was to read a textbook about it? The only way you could figure out anything about American history was to read a textbook, page 1 to 1,000. What if I removed page 15 through 20? It's a missing piece of history. What if that was the Civil War? Would you ever know it happened if those pages were missing? No. So this is the same idea. When you remove a layer, whatever history was in that layer is now gone. So you would never know, you would know there was something there because there's a little pink piece left behind, or there's a scratch from the glacier. But whatever important information was in this layer is now gone. So what we like to say is, yes, it's a buried erosional surface. Oh, wait, how does it get buried? So here's an erosional surface, a place where erosion has happened. How does it get buried? We put new stuff on it. So new sediments get deposited. So again, that old layer, actually I should probably put another purple layer. The old pink layer has been moved away, and now where it was gets covered up by new rock. So that's how it's a buried erosional surface. But the other part of it, the second bullet that's almost as, if not important as the first bullet, is it's, they call it a gap in geological history. The gap in geological history, meaning whatever history was in that layer is now missing. Just like if we ripped out pages of a textbook, whatever information was in those pages is now gone forever. How is this shown on the rock layers? So if we had rock layer A, rock layer B, but C is the one that gets removed. So if C was when the glacier came through, they will show that with this thick, black, wavy line. And then layer D would have been deposited on top of that. So this thick, wavy line is representing an unconformity. It's a missing layer, a missing piece of time. So that's what that's what was missing for potentially correctly answering question 1. Can you reread question 1 and see if now that you have more of an understanding of what an unconformity is, see if you can answer that one more correctly. So an unconformity, a buried erosional surface, provides evidence that. Now that we've learned what an unconformity is, what's the answer here? Yeah, it is answer 1, that a part of geological history has been destroyed. Yeah, sorry about that. I don't understand why I didn't do that first. Question 2, again, you had to make sure you read carefully. The diagram below represents a cross-section of the portion of the Earth's crust. A through D represent locations in the bedrock. The rock layers have not been overturned. Which one happened most recently? And by saying most recently, are they looking for the oldest or the youngest rocks? Youngest. That's something that I sometimes stop and kind of confirm in my head by saying most recently. So again, if I was to ask which one of you were born most recently, it would be whoever's the youngest in the room. So same here, this is the youngest. They only give you 4 options. Now, first of all, where do you typically look to see for the youngest? The top, yes. But there's exceptions to that. Remember, we talked about those yesterday. Faults can mess up the youngest being on the top. Intrusions can mess up the youngest one being on top. And erosion can mess up the youngest being on top. So out of these 4 choices, yes, you could just look at the layers, but I like to look at the choices first. So they tell me limestone. They say siltstone, which is this one, shale, which is this one, or gabbro, which according to right here is this one. Out of those 4 choices, which one is the youngest? It is the gabbro. Typically, this question will have a follow-up short answer question. And it will be, how do you know it's gabbro? It is because of the little contact metamorphism marks. Again, and so I'm going to add that, because there is contact metamorphism on each layer. A lot of people, so even Rayleigh's answer of the little contact metamorphism marks would not be good enough. You do need to have a complete thought. So don't just answer it because of the contact metamorphism. Tell me, what about the contact metamorphism? So it has to be explaining that there's contact metamorphism on all the layers. So in fact, how about this? Is the gabbro younger or older than this layer of sandstone? It's, again, still younger because there's contact metamorphism on the sandstone. Right. So it has to be there to get that contact metamorphism to change. I have, well, we'll keep going. Never mind. Which of these events occurred most recently at this location? Again, you could just look at the diagram, but I think it's easier to narrow it down by looking at the answers first. The faulting of rock layers B, C, D, and E. The intrusion of the basalt, the formation of the limestone layer, or the metamorphism of the granite. Let's go through process of elimination. The first one says the faulting of B, C, and D. Was that fairly recent? It was. Could be. So, oh, and E. Is that true? Is the fault younger or older than E? How do you know it's younger than E? Right, because it's broken. It had to be there to be broken. So this is definitely a possibility. How about the intrusion of the basalt? Is that the most recent? No, we just talked about that. The fault was younger than that. How about the formation of the limestone? Is that younger than all the others? Nope, because it was broken. We know the fault was younger. And how about the metamorphism of granite? That's down here. Granite being touched by the intrusion. Is that the youngest out of all of those? Nope. All right. The fault is the youngest. Which evidence is there that there's a gap in geological record represented by this cross-section? So again, now that we know about this, which one of these represents a gap in the geological record? Anybody? Just learn about it. D, a buried erosional surface. Again, how do they show that? See, and they do say here, this buried erosional surface right here, that wavy line is representing an unconformity, which means erosion came through. This one is taking what we've learned the last week or so and taking it and combining everything we've learned. What do you see in these rock layers? Fossils. And what do we know about, for example, this fossil right there and that fossil right there? They're the same fossil. And these are not random fossils. They are the index fossils on the bottom of this page. So in fact, that's this guy, letter Z. We know that Z only existed for this small period of time. So the fact that there are two of the exact same thing tells us those two layers, oops, and this guy right here, those three rock layers are the exact same age. So they want to know which one of these rock layers, A, B, C, or D, is the absolute youngest out of the four of them. Where do you normally look for the youngest? The top. But we have a problem. A's on top, C's on top, D's on top. How do we go about figuring out which one's the absolute youngest? How about this? Is it easy to eliminate some of them? One is real easy to eliminate. I think I heard somebody say it. Which one can I eliminate with not much thinking? Huh? B?
Wouldn't it be A because there's two of them?
Okay, that'll help, but that's not really the reason I can definitely eliminate it. Let's look here. Which one can I absolutely eliminate as being the youngest? Which one? A. Why can I eliminate A as being the youngest? Because C is younger than A. See how C is on top of A? So we know that A is absolutely not the youngest. Can we do the same thing over here? Which one's not the youngest here? C is definitely not the youngest because D is younger than C. So if it's not A and it's not C, that leaves B or D. Now this one's looking hopeful because D is on top. Here's B, but we can't just look at the very top and decide that's the youngest. We have to compare it to the fossils. Here, B and the fossil. What do you see about B and the fossil? B is even older than the fossil. What do we notice back over here with the fossil and A? A was younger than the fossil because it's above it. So here, if B is older than the fossil, can B be young? No, B's pretty old because it's younger than the fossil, or older than the fossil, sorry. So the one that is the absolute youngest is answer A, which is letter D. Yeah, again, the computer just scrambles them. Sorry about that. I try to fix it when I catch it. How about in this case, which one's the youngest? Now, typically we look for the layer that's on top. But now we have this, in this case, it's an extrusion. Which one's the youngest? Answer A. In this case, it's an extrusion. It came through. D was there. C was there. B was there. A is the extrusion. Made it to the surface. It is the youngest. And this one, which one occurred most recently? The fault, the intrusion, deposition of rock layer A, or the sedimentation of rock layer D? Which one can you get rid of without much thought? D. Why is it definitely not D? Because D is on the bottom. D is going to be one of the oldest things. Everything else has happened since D was there. How about, which ones can we go through? Is the fault younger or older than E? Older. How do we know the fault is older? Okay. Did E get broken? Let's start there. E did not get broken. So E was put there after the fault. So we have to decide, is it E or A? E. How do you know? There's contact metamorphism on A. That means A had to be there. E got deposited later. All right. So it was a little bit of work. And what we're going to do is all we have left to do then is, yep, we left it off here yesterday with where and how everything was formed. So if you remember what we went through yesterday, we just listed these in order from oldest to youngest. You will put your phone in your AirPods up there. Anybody else?
Yeah, but I wasn't on my phone.
Yeah, but your AirPods are in, and that's the same thing as being on your phone. Put your phone up here. Put your phone up here.
Or
Because you're not allowed to have your phone or AirPods. Well, so we went through yesterday. Which one's the oldest? Which one's the youngest? And we put them in order in which they were formed. That's another way that Regents is going to mess with you, is just changing the words they use. Order in which they formed means starting with the oldest, going to the youngest. We went through the whole thing. We recolored it. We colored it. I cut it out. You saw that it looked, all right, like this when we re-put it together, making conglomerate the oldest, and we went through the order. But now they're going to combine some older chapters that we've done. And they're going to ask you where or how and where these rock layers would have formed. So you're going to need your reference table out, probably your actual reference table, so that you can look at the rock charts. So the first rock was conglomerate. Again, a sedimentary rock. How do sedimentary rocks form? Sediments. So first of all, yes, weathering and erosion makes sediments. Then what happens to sediments? Deposited, buried, compacted, and cemented together to make sedimentary rocks. That is you're going to have to include most of that when they ask you, how did they form? But we got to take it a step further. That first rock was conglomerate. What kind of sediments is conglomerate made out of? So this is flashback to chapter 3. What kinds of sediments is conglomerate made out of? So take a look at conglomerate. What is it made out of? So not this column, not the composition. We want the size. Conglomerate's made out of pebbles, cobbles, boulders, embedded in sand, silt, or clay. Are pebbles, cobbles, and boulders, how would you define those types of sediments?
Small.
Pebbles, cobbles, and boulders? Those are big ones, in case you forgot. Pebbles, cobbles, and boulders, they're the bigger sediments. So how you're going to word this is conglomerate is made when large sediments are deposited, but then they want the environment. Meaning, where do they get deposited? What's the #1 agent of erosion? Running water. So most sediments, if that's the #1 agent of erosion is running water, then most sediments get deposited by running water. Where in the water will large sediments get deposited in water? This was last chapter. So remember, when we have a stream that enters into a lake, where do the big sediments get deposited? Are you sure? The beginning of the lake, right where it enters, will have large sediments, followed by medium-sized sediments, followed by the smallest sediments as you get deeper. So how we talk about large sediments, these guys, they get deposited in shallow water. So the large sediments don't make it very far out into the lake. So we say the large sediments get deposited in shallow water. We have to do this for each layer that's listed. Let's do another one. Shale. Take a look at shale on your reference table. What kinds of sediments is shale made out of? Clay. Oh, sorry. Clay. So how you can word this, you could say small, but because we know exactly what sediments clay as shale is made out of, it's probably better to say clay-sized sediments or just clay. You could probably just, yeah, if you wanted to shorten it, you could just say clay deposited. And is clay a large or a small sediment? It's as small as it gets. Clay is the smallest. So in terms of the lake, where is clay going to get deposited? The last dot. So again, to clear that, or to make it simple, we say in deep water. So again, we got to keep doing this with each one. So we're going to do sandstone. What is sandstone made out of? Sand. And what's Scott? So we can say again, sand deposited. And what is sand? Like size-wise? So it's here in the middle. It would be these middle guys, these middle dots. Would you call that shallow or deep, or can't you name it? It's in between. So for the middle guys, we actually just say deposited in water. The only ones they make sure you understand are the tiniest particles and the biggest particles. The tiniest are in deep water. The big particles are going to be shallow water. So if there are these guys in between, so silt and sand, those are the two that are just deposited in water. So speaking of siltstone, what is siltstone made out of? Silt. And because it's not the smallest and it's not the largest, we just say in water. Almost done. Limestone. What's limestone made out of? Calcite. Limestone's made out of calcite. Precipitate of biological origin or cemented shell fragment. So you get broken pieces of clam shells or some skeletons. Where do you think they're going to get deposited? Are they really small, really large? They're not. So again, we just say deposited in water. How about breccia? What's it made out of? Pebbles, cobbles, and boulders. So you could summarize pebbles, cobbles, and boulders by saying large sediments. Deposited, where again do we have large sediments deposited? Shallow water. In shallow water. The next one that we said yesterday was an intrusion and contact metamorphism. How is an intrusion formed? What is an intrusion? Lava. Lava. What does the lava do to cool and harden? Oh, wait, I just said it. What does the lava do? It cools and hardens. Cools. Where will an intrusion cool? Lava cools inside Earth. I guess technically then it's magma, but that's fine. How does a fault happen? Plate tectonics. On Earth again. So plate tectonics break the layers. And the last thing we added yesterday was erosion happened on the erosion happened. What are some things that cause erosion? Water, wind, waves, gravity, and glaciers. You can sum this up by 5 agents of erosion. Where does erosion happen? On Earth's surface. What I want you to do, it's not going to be homework. So it will be homework, but you're going to finish it now is what I'm getting at. There is a story here. We're not going to read the whole story, but what we're telling you, so it's supposed to be about NCIS, blah, blah, blah. You find the history of the age of the Earth. You find a dead body in there. Notice each layer has a dead body. If you are familiar at all with those crime scene shows, they really want to figure out what happened. So here we're going to say, when did it happen? Let's turn to page 24. Page 24. Yep. What I want you to do is put these rock layers in order from oldest to youngest. We'll leave the rest of the part of this blank. Just give me the number or letter of this one page. Oldest to youngest. This, by the way, is a number 1. The 7 goes with the polka dot layer. The 2 is the dead body. So I do want you to include the dead body. There is a perfect number of things, of blanks. Okay, so all you're doing for homework is this one page in order from oldest to youngest. The what? Yeah, so this one doesn't have a number, so you don't have to include it. Okay, so just numbers 1 through 9 include letters X and Y. There is the perfect number of spaces for the order in which they happen. So again, you are just doing that column right there. Any questions about the homework? Okay. What you got, Logan?